Hey everyone, and welcome. Today, we're diving into a really cool idea from the book The Programmer's Brain. And it's this: if you want to seriously level up your coding skills, you first have to understand the code that's already running inside your own head.
We've all asked ourselves this, right? Is it just about putting in more hours or knowing a dozen different languages? Well, those things are part of it, sure, but they totally miss the most important piece of the puzzle. The real difference maker, it isn't in your computer, it's inside your brain.
And that's really the heart of it all. See, every single time you read code, write code, or even just think about code, there are these specific cognitive processes firing away. The secret to getting better isn't just about grinding it out. It's about learning how to work with your brain's natural systems instead of constantly fighting against them.
So, let's start this off by stepping away from the screen for a minute and taking a look inside the mind. Because, we've got to understand the hardware we're all running on before we can even hope to optimize the software.
The best way to think about it is like your brain is this mental workshop. First, you've got this absolutely massive library. That's your long-term memory, where every single thing you've ever learned is stored. Then you've got this tiny little workbench, your short-term memory, and it can only hold a few things at once. And finally, you've got the processor, your working memory, which is you actively thinking and messing with the stuff that's on that tiny workbench.
Okay, so let's start with that vast library, your long-term memory. Its real power isn't what you probably think it is.
See, your LTM isn't just some big, boring list of syntax rules. It's more like a complex, living network. Its real magic comes from how it connects new information to stuff you already know. An expert programmer has this incredibly rich, interconnected web of concepts in their LTM, and that's what lets them see the big picture almost instantly.
This whole idea is perfectly shown in a classic experiment with chess players. So, you show a chessboard to an average player and they try to memorize where every single piece is. Their workbench gets overloaded in seconds. But an expert? They don't see pieces. They see patterns. They see chunks. They use their LTM, their library, to instantly recognize, oh, that's a Sicilian opening, and that whole complex pattern takes up just one single slot on their mental workbench.
And this is exactly what happens with programming. A senior developer isn't just reading the syntax, for int I equals 0, ... They're instantly seeing the concept. Okay, this is a loop iterating through an array. They've chunked all that syntax into a meaningful pattern, all thanks to that well-organized library in their head. This is the superpower that lets them grasp incredibly complex code so fast.
All right, so let's move from that giant library over to the mental workbench. This is where all the real-time thinking happens. And believe me, it has a serious limitation.
That's it. 2 to 6. That's the total number of distinct items your workbench, your short-term memory, can hold at any given time. Not a dozen. Not even the old 7 plus or minus 2 idea. The latest research says it's probably just 2 to 6 things. This is, without a doubt, the single biggest bottleneck in our ability to think through complex problems.
And you know that feeling, right, when your brain just feels full after staring at a complicated function? Well, that feeling has a name. It's called cognitive load. It means your working memory, your processor, is completely maxed out.
Now here's the crucial part. Not all load is the same. Intrinsic load is just how hard the problem is naturally. Some things are just complex. But extraneous load, that's the junk food of thinking. It comes from confusing variable names, messy code, weird syntax, and this is the part we can actually do something about. We can reduce it to free up that precious mental bandwidth.
Okay, so we get the systems, we get their limits. Now for the fun part. How do we actually start hacking these systems to work for us, not against us?
So, to build a better library, you've got to be intentional. Flashcards, they're amazing for just drilling new syntax into your head. Then there's spaced repetition. Revisiting a topic every few days, then a week, then a month, it's scientifically proven to be the best way to fight the forgetting curve and build really strong memories. And finally, elaboration. Always be asking yourself, okay, how does this new thing connect to something I already get? That's how you build those powerful mental networks.
And to manage that tiny workbench, you have to learn to offload the strain. If some crazy Lambda function is melting your brain, just temporarily rewrite it as a plain old function. That's called cognitive refactoring. Use a pen and paper. Seriously, draw out how functions connect or track how a variable changes. These are memory aids. And of course, the big one. Use clear names. A variable called max_login attempts takes way less mental energy to process than just x.
So when we put all of this together, what does it actually mean for us as developers? Well, it points to a pretty fundamental shift in how we should be thinking about getting better at what we do.
This quote just nails it, doesn't it? Expertise isn't just about throwing yourself at harder and harder problems. It's about mastering the process of learning and understanding itself. It's about building the cognitive tools that allow you to solve those expert-level problems in the first place.
So here's the big takeaway. The path to becoming a truly great programmer isn't about being born smarter. It's about becoming a master of your own mental workshop. It's about consciously building up your library, managing your tiny workbench, and clearing all the junk off your processor so you can actually think.
And that leaves us with one last thought to chew on. We've been talking about code, obviously, but these principles, memory, chunking, cognitive load, they apply to literally everything. So how could you use this stuff to make your meetings better, your design process, or even how you teach new people on your team? Think about it. Thanks for tuning in.